I'd like to share my latest project, eosio.evm, Ethereum virtual machine on EOS.io. We've been able to achieve stellar benchmarks with this project, with entire ERC20 deployments taking less than 1 microsecond, ERC20 transfers taking around 500 microseconds, non-ERC20 base level transfers inside the EVM taking only around 300 microseconds, and similar. And this has all been thanks to the great advancements at Block 1 with EOSVM. In this video, we'll be going further into a tutorial for deploying the EVM and deploying the ERC20 contract using our full JavaScript SDK. So go right ahead and type in github.com/jaffrey/eosio.evm to follow along with the tutorial. Once you're here, click the EOS EVM JavaScript, which will take you to the JavaScript SDK page. And here, click the examples and go to the ERC20 example. Copy this code in and copy it to your editor. Here, I've already copied it into my VS Code, and I'll be going through all of these things in this example one by one. So, starting off, you must have the EOS EVM JS library installed, and the command for that is simple. In your console, type in npm I EOS EVM JS. You have to make sure you have Node.js and EVM installed and npm installed. So here we've specified some constants. The EVM contract account constant represents the EOS account that we'll be deploying our EVM contract to, which is EVM contract 1 here. The EVM normal account is the account that we'll be using to interact with our EVM. And the system symbol, which you specify, it must match the system symbol that you compiled the contract with. Since we're using Jungle testnet here, the symbol is EOS. So we can see that the first thing that you must do is set up the EOS EVM API with some parameters. The first parameter it takes is endpoint. This is a normal EOS.io RPC endpoint, and we've specified jungle.eosdac here since we're using the Jungle testnet. You have to make sure that this API has console printing enabled, since that's how the EVM talks back to the client. Then you specify the chain ID. The chain ID must match the contract it is compiled with. And then you can specify Ethereum private keys. This is not necessary. It's an optional parameter, and it's only necessary if you want to sign transactions directly using the Ethereum private keys instead of using the EOS.io authorization permissions. And eosio.evm supports both according to the challenge specs. Next, you enter in the EOS contract, which is the address, the EOS address of the contract that we'll be deploying our EVM to, and the EOS private keys. For here, we've specified both the contract and the account that we'll be using. So let's go right ahead and start our debugging. So we've set our first breakpoint to importing in compiled ERC20 and ERC721 contracts. eosio.evm provides these two contracts already compiled. You're free to compile your own using solc and import in the output JSON similar to this. Next, we call the API load contract from ABI function. Here it takes 3 parameters. We pass in the account, the EOS account name for the account that'll be interacting with the contract, the ABI, and the bytecode. Next, we'll start the main functionality of the program, and we'll start off by setting up the EVM contract. So to set up the EVM contract and deploy it to the EOS account that we specified earlier, all you have to do is call api.eos.setup.evm contract. And here we've already set it up on this account. Um, so we go to the debug console and step over once more. We will see it prints that the same code already exists. If it's the first time you're doing this on a new account, it will deploy it using the set code and set AVI functions automatically for you. Next, this is a function only for testing. It's the Clearall function. And once in production, this functionality is turned off in the contract. But here, since we're doing development, it clears all the data, all the account and account states, so we can start afresh. And now we get into the actual execution part. So the first step that we do is we call api.eos.create. We pass it in the EOS account name and an arbitrary string. The contract does an RLP encoding of the EOS account and the arbitrary data to generate a new address linked to your EOS account. So if we execute that, and now we go back to our browser right here, we can pull up the EVM contract right here, refresh the actions, and we see that it has already called the Clearall and create actions. And create, it passes in the EOS account name and the arbitrary data. And when we go to the contract to look at the tables, we see that it has created a table entry for this address linked to our EOS account. So next, we'll deposit some EOS into this account. We'll be depositing 0.002. And similarly, if we refresh the table here, we will see that the balance has updated to 0.002 EOS. And this happens simply from a normal EOS.io transfer, as we can see right here. A simple transfer to the contract finds the linked account to this EOS account and deposits it into that address. Next, we'll be showing how the JavaScript SDK can actually fetch all this data directly. Here we call the getEth account by EOS account, and we pass it in the EOS account name to find the linked account. When we run this, we will see that it has found the sender. If you look at the left here, it has found the EVM account 11 with all the data, including the nonce, the current balance, and even the code if it was available. Next, we'll be deploying the ERC20 contract. We have completely made this very easy for developers by making it a single line to deploy the entire contract on eosio.evm. And the parameters we pass in is the contract name, the symbol, the precision, and the supply of the token. When calling deploy, it's important that when you're calling in an EVM Ethereum function using our JavaScript SDK, in the last parameter you specify the sender, and the sender would be this account that we created right here, the sender.address 0x4AA, etc. So let's run this ERC20 contract. So it's been deployed. Let's go right here, refresh, and we see right here the raw action has been called and the contract has been deployed. As you can see, this contract deployment, the ERC contract deployment initialization only took 627 microseconds. If we go to the traces, we can actually even see, we see the nonce increment. We see that the new address was created because this was a contract creation transaction, and the initial data was stored all right here, and the code was placed in. So coming back to our example here, now we can actually call api.eth .balance of, and now balance of, for those of you who might be unfamiliar, is a view function in Ethereum. So view functions don't modify any state. So with libraries such as Web3, Ethereum developers can actually simply call this function without having to actually pay any gas or the sort. And we've implemented a similar thing in eosio.evm. So if we see here, we call we print it and we see that we have a fire balance right here in our initial address of 1 million, a 1 million fire balance. And if we actually go back here into our contract, EVM contract 1, and double check, there was no transaction sent actually. What we do is we have a special call function that asserts every single call. So in a way, it's a getter function. You call it to any blockchain node, it returns the result as a form of exception, and our SDK automatically catches that and presents it as an output. So moving forward, next what we're going to do is a native EVM transfer. So this is not a fire token transfer. This is a native transfer of 0.001 EOS to a new address that we will call the receiver address. And this, by transferring money, we will actually create the account row in our account table. So once again, let's step right over. The transfer has been completed. And once again, if we go right here, now we actually see three addresses. Our initial address that we created linked to our EOS account, the code account with the ERC20 contract, and a new account that we transferred EOS to. We see that the balance is updated. We had 0.0002 EOS initially. We transferred in our last action here, and the nonce increments have been happening perfectly. So now what we're going to do is take it to the next step. Now we're going to do a eth.transfer, which the .eth prefix means that we're calling the Ethereum contract that we loaded in. So we're going to do a ERC20 transfer right here. And remember, whenever we do ERC20 transfers, the last parameter has to pass in the sender. So we're calling as our initial sender. Let's transfer this 1,000 fire tokens. And then we will once again call the balance of functions to get the fire balances. And right here, we see right here that the balance of our fire tokens is 999,000 for our sender, because he sent 1,000 fire tokens to this new address. And if we go back to our contract, we see that this transaction was the native EVM transfer, and this transaction was the ERC20 transfer. The rest of the tutorial is just some other functions from ERC20. We have, since it supports all actions, you can call any action on the contract directly like this, like f.approve, increase allowance, decrease allowance. And once again, we use another view function that is specified already from compiling the contract. When you compile your Solidity code, it generates this, the ERC20 contract has an allowance view function, and we can call it natively here. And if we continue once more, we'll see that the allowance for transferring is 500, since we did an initial allowance of 100, incremented it 1,000, and subtracted 600. And similarly, to finish it off, we have the ability to withdraw EOS balance out. And actually, this transfer form function is another function on the ERC20 contract, which uses the allowance parameter to check how much you're allowed to transfer. And all that does is it allows someone else to allow you to transfer their tokens at a future date. And So now we've executed both the transfer form and the withdraw actions. If we come back here and refresh it, we will see that it was withdrawn out to our account, calling the withdraw action, and also the transaction before it was the transfer from, after all the approvals. With that being said, there's some other actions if you want to play around. If you know the key of if you know the key of the transaction already, you can use the get storage at function. And if you want to create a raw transaction, you can use this. If you want to get the nonce or get the Ethereum account by passing in the address instead of the EOS account, as we showed earlier, you can do all of that. So it's a very versatile tool set, very similar to the Web3 tool set that Ethereum developers are already used to. And we're going to continue to work on it and improve it. Thank you for following along in this tutorial.